Hello and welcome everyone. This is going to be the first basic dimensioning lesson for orthographic drawings. And obviously we're going to start with the feed stop, which was the first orthographic drawing that we had started. Now, this is not going to be as simple as copying the dimension placement in the correct projection plane that you see on this sheet. We are going to be having to make some adjustments to this, and we're not going to need all these dimensions either. We want as little information as possible to be able to dimension the drawing correctly. So let's take a look at the hub and take a look at this note, Basic Dimensioning Rules for Orthographic Drawings. This is an 11-page document that I had created, and I had used an example for my grade 11 course, a drawing here, used to show you what is correct and what is incorrect. So we're going to be going through this list and discussing a few things. Now, this is a reference to assist you in becoming a pro at detailing, meaning dimensioning mechanical drawings. Number 1 says place dimensions off outside the views. So it shows you what is correct and what is incorrect. There's usually one example, possibly two examples in this note. Now, when we take a look at the feed stop in its isometric form or 3D form, we notice there's dimensions sitting on top of the views. Now, this is something we can't duplicate in the orthographic drawing, so we have to understand that at the beginning, that all the dimensions we place are going to have to be placed outside of the views. Number 2 says, do not place dimensions between the views when possible. It says you can place a dimension between the views if the feature you are detailing is more easily understood to the person who will be manufacturing the part. Hint, dimension features that show a defined profile rather than a flat 2D perspective. So basically, this is a gray area in our rules for dimensioning a drawing. So you can place dimensions between views. It would be silly to think you could never do it, but we want to avoid it if we can. We only want to put dimensions between views if there is an advantage to it, because otherwise it creates too much crowding. So in this correct example versus the incorrect, everything is the same. The only difference is the height of this extrusion and this rabbit right here is shown on the inside between the front and the right side view. In the incorrect, it's shown over here. Like technically this is a gray area, so it is correct to do this, but these dimensions are better understood on the front view, where there's a defined profile of the part. So this is, in the incorrect right side view, this is basically just flat 2D perspective. So this is easier to understand. I'm going to zoom in on this a bit. So this is preferred, and this takes a little bit of practice to understand. So there's actually two examples for this one. So again, in the correct picture, we're showing that this vertical flange on the control bracket is 3/4 inches. Of course, I could dimension it up here, but it's better understood on the front view where we clearly see a defined profile of the shape of the control bracket. Now let's take a look at the 1.75 and the 1.5 dimension on the top view. Their dimension on the top view between the two views. Again, so we already have our 3/4 dimension here, and we also have our 1.75 and 1.5 dimension. But what is the advantage of having these two dimensions on the inside? If we look at the correct photograph, we're going to see that they dimension exactly the same on the other side of the part. So why not keep these dimensions outside and create less crowding? So you have to understand when there is an advantage and when the advantage is not there. For these two dimensions, there is no clear advantage to have them crowding with the 3/4. It makes sense to have them on the outside. This looks better I'm sure you can agree when you look at it, it's better to have this looking less crowded between views. So it says here, placing dimensions between views with no necessary reason creates crowding. Exactly what I said. Number 3 says dimension each feature only once and only dimension to object lines or center lines associated with object features. Do not dimension the hidden detail lines or center lines that are associated with hidden features. So in this example here, in the correct slide versus the incorrect, we're seeing this 0.75 dimension and this 1.75 dimension on the outside of the front view, but that center line is attached to these hidden lines. So this is a complete negative. So you should never ever dimension anything to a hidden line or a center line that's associated with it. So these two dimensions here need to be placed on the right side view on the outside to prevent crowding and where the object is visible. So this hole here is visible on the right side view. It's not in hidden detail here, it's an object view. Now, on the incorrect slide, why do I have these dimensions twice if I have them over here, even though they're wrong over here? And why do I have these two dimensions twice? Because this is incorrect. There's no reason to duplicate dimensions on multiple views. So when you're dimensioning an orthographic drawing, you list one of the dimensions on one of the views in the correct spot and leave it at that. So if you're running the dimensions all over all the views, you're creating crowding. It's too many dimensions. It's incorrect. Remember that we want the bare minimum of information of dimensioning on your drawing, right? It just confuses the person in the shop if they have to look at the dimensions all over the drawing when they're not required. All these other dimensions are fine. The radius 1/2 inch is listed once. The 3/4 is listed once. The R 5/16. The 2.63, it's just these ones here are duplicated and they don't need to be. This one's very simple, number 4, and everyone should be a pro at this already, especially if they're working in grade 9 or 10. Place the first set of dimensions 12 millimeters away from the edge of the drawing view, and the second set and every subsequent set 10 millimeters away from the previous stack, and that lists AutoCAD only. People that use Autodesk Inventor don't have the luxury of snapping the dimension right in line with the view and then using a grip to extend it a certain distance. So there's a feature in Inventor that allows the dimension to basically break every so often as you pull it off the part, and that gives you an indication of where to drop the dimension to keep the spacing looking proper and correct. So reference that 5/8 dimension. So after the vertical line is selected, to add this to the drawing, as you pull your mouse slowly from the vertical edge, the dimension extension line and arrow leaders will turn dotted. So this is something that we worry about in Inventor. It doesn't really apply to grade 9 and 10. But that image shows what we're talking about. As you pull a dimension off the part, it becomes dotted, and that's where you know where you should drop it. So it's kind of like an automatic way of creating your spacing. Number 6, dimensions must be consistently spaced from one stack to the next. So look at the correct example and look at the incorrect. So we always want to dimension the smallest features first and work our way out to the largest. In this incorrect example, we're running the overall height first, then we're running the height of this vertical face at the back, which is 1.25 inches, and the 1 3/8 and the 4 inches here are too close together, and this 5/8 is way out here in the breeze where it shouldn't be. So again, Dimensions have to be placed a certain distance away for consistency and professionalism, and they have to go smallest to largest as we work our way out. Just like it says here. Inconsistent spacing when adding dimensions results in a drawing that does not look professional. See examples above. Always include overall dimensions on one of the views in your drawing. So we're going to want to have on one of the views at least an overall length, an overall height, and an overall width. Right? This is something that should be included. And then usually we would leave one dimension out of the chain, because if we're showing the height is 2.5 and we're showing from the top to the circle, the center of the hole is 3/4. If I had a dimension running from here to here, that would be over dimensioning, right? It's too much information. So it's better to have the overall versus having just a chain of dimensions running a whole height or length or width, because then the person in the shop has to basically get their calculator out and add them all up one by one just to figure out how large the piece of stock he needs to cut off at the saw needs to be. So it says here, reference the 2 inches on the top view, the 4.25 on the front view, and the 2.5 on the right side view here. 8. Always make sure arrowhead leaders in a chain of dimensions line up with one another. This is very simple. We look at what is correct. The 9/16 chains up with the 1 1/8. And we look at the incorrect example. The 9/16 is sitting lower than the 1 1/8. So all these arrowheads need to chain together. And it references those dimensions here that I discussed. Moving on, I talked about this a couple of pictures ago. Number 9 says omit one dimension in a chain of dimensions. So exactly like this. In the correct picture, we show the overall width. We also have it on the incorrect, but we leave one dimension out in a chain. Here. Again, this is over dimensioning. It's preferred to have the overall width, one dimension, but why have all 3 of these as well? Again, this is considered too much information. It's considered overkill. And it says right here, it is preferable to keep the overall dimension and delete a detail from the chain rather than display the opposite. All right, we're on slide 10 of 11. So number 10 says, dimension features that are obviously identical only once and include a suffix tip on the end. So here we go. We have this radius is listed as 1/2 inch typical. Now this is something we saw in the carrier frame drawing when we were working on that. Again, why do I need to show this twice? It's obviously the same feature on the right side, and it also creates over dimensioning. So this arrowhead leader now has to cross over the 3/4 inch dimension extension line, right? This is much cleaner, less work, easier to just put a typical. So again, this example is an example of over dimensioning. The drawing will become too cluttered with the same dimension repeated over again. Tip stands for typical. See one more example below. So it says, looking out at the example on the left, by adding a 9/16 tip, makes it very clear for the person who is manufacturing the part that the dimension is identical to the space above. Adding a tip on the end of the 7/16 hole allows for less detailing. And then you can see that example here, right? So again, we're dimensioning the 7/16 twice on each hole on the incorrect. I can just have it once and put a typical on the end and be finished with it. And also, it's easier to know that if this width is 9/16, again, it's very clear to the person in the shop that that's typical on this side, right? And this does not break the rule of over dimensioning, because I don't have a dimension running from here, this top line, to the center of the center line in the hole. So in conclusion, right, after all this information is kind of thrown at you, in conclusion, we are trying to clearly detail the part by showing the least amount of information, dimensions meaning, that's what that means, as possible. So this is here for reference. Now, when we look at this is breaking some of those rules, right? I see the 14 dimension here twice, right? I don't need to show it twice. This can be a typical dimension, right? The 27 is shown 3 times here. Again, we only really need to show it once. I say the dimensions that look correct are the 22 and the 33 in their position. The R7, the radius 6 should be off of the part. And we're going to clean up how these ordinate dimensions, that's the correct term for dimensioning arcs and circles. We call it ordinate. We're going to clean that up a bit because there's just too much text being shown here. Okay, so we're going to get started, dimension this feed stop correctly. So we need an overall height, and we're going to be able to satisfy that with the 50 dimension. So I'm going to start with the linear dimension. I'm going to dimension from this endpoint to this one, snap it in line, and then use a grip and bring this out 12 millimeters. Right, that's going to represent the 50 dimension. That dimension is perfect where it is, and it satisfies our overall height. Now, moving onward, on the right side view, the 22 dimension, which dimensions from here to here, this has to be snapped in line with the part and brought out 12. Now, we may change this, but we'll see how things go. Right, this dimension here, as you go, if you'd like, you can throw these on the dimension layer. We also have to show the radius of 6 here. So we're going to go into our dimension tools. We're going to grab radius dimension. We're going to select this radius, and we're going to come down. Now, we can't actually snap this really 12 millimeters away. Like we could snap that there, and we really can't bring it down the way we're used to working with the linear dimension. So we're just going to basically eyeball this dimension to be something like this. And this is pretty close, and we're going to be happy with it like that. It's also a good idea to try and not cross over line work if possible, so we're going to correct this. So I'm just going to redo that dimension. Pick radius, select here, come down. We're going to have to cross over one hidden line, and we're going to drop it about there. And that's going to be correct for us. We also have to show the radius 7. So we're going to run another arc dimension here. And this one, we can kind of use this as a reference point, right? So I want that R7 basically to be eyeballed as best I can right in line with that 22. So this, we're not going to snap. We're just going to eyeball this and make it look correct. So that would be good enough like that. And we're only going to be adding the dimensions that we see on the feed stop. We're not going to be making up dimensions that don't exist. We're only going to be better positioning the information that we have. Okay? Moving on, we have to show the height of, or the width of that flange here. So we're going to go linear dimension. We're going to dimension from here to here. Try that again. I think I snapped it wrong. From here to here, 14. We're going to snap it in line with the part. We're going to come up 12. And we're also going to exit the command after running that dimension, and we're going to double click on this dimension. We're going to put the cursor on the right side, and we're going to type in all caps tip. Now that doesn't want to fit, so what we can do is just kind of pull that text off to the side like that. And the reason I pull it to the left is because we don't want this to basically crowd here unnecessarily, right? So this is fine like this. And that's also going to tell the story that this base is also 14 millimeters high. So I don't need to run that dimension, right? I'm cutting down on my dimensioning by using typicals. There isn't a lot of dimensions to this drawing. Next up, we have the 27. So I can run that dimension on the top view. I can run it from here, this endpoint, to the center line, snap it in line with the part, and then use a grip and bring it out 12 millimeters. Now, running this dimension again from here to here, this is incorrect because this is over dimensioning. Again, I don't need the 27 anyway because I have a center line here that runs through this that represents symmetry. So the center line should tell the story that if from here to here is 27 and this is a symmetrical view, which it is, this dimension is not needed. So we are going to get rid of it and erase it. Remember, the feed stop shows 3 27 dimensions. We're only going to need 1 for our orthographic presentation. Moving on, we're going to do the diameters of these circles here. So what we can do is run a dimension of 64. So we're going to go diameter dimension, and we're going to drop this on here like this. We're going to drop it, make it look around 12 millimeters away as best we can, right? It just should not be crowding like this. It shouldn't be right up against the border. We should leave ourselves a little bit of space so it looks nice. Like in this case, we could have this dimension, I would say about here. And that looks good. We're going to right click, repeat dim diameter. We're also going to run the 41 dimension. We can run that one here. We don't want to crowd it, right? We can't really space these out 12 millimeters and 10 millimeters, but we don't want to crowd it. We want to leave some space, drop it around here. Now, how do we dimension the height of this counter bore hole, right? If I ran a dimension like this to show that, I don't have room to do it on this side because the radius 7 is here, so I would be forced to run the dimension from here to here and bring it out 12 millimeters. This is wrong, right? This cannot be done because I can never ever run any dimension to any hidden detail line. But all there is hidden detail for that counter bore. I can't see any perspective of it on the top view. I can't see it in object line on the front view or the right side view. So what am I to do? I'm going to delete it. This is what you're going to do. You're going to go up to the 41 dimension, double click it, and like we had done before, we're going to say 12 deep. Like that. right? Like the same way we had edited the typical dimension for 14. So we have to adjust this. We're going to have to bring this in like this. And you can get greater control of moving these ordinate dimensions if you turn the ortho off. So if I turn ortho off, I got better control over manipulating it on the screen. And that's something I should have shown you down here when we were playing with these radius dimensions. Again, we're going to leave that the way it is. We're going to select these dimensions. And we're going to throw them on dimensions layer. Okay. And this one too. Okay, so we're almost done. We also need to show the inner hole here that runs right through. That is going to be 21. So we'll run another diameter dimension, pick this circle. Now we're getting a bit crowded here, but we could fit it here. We could even bring it down here, which would look good, and kind of keep it in line with the 41. So I'm going to place mine like this. So all three of these circles are identified. We've identified the width of this base with half the vertical flange. We know the height of the cylinder. We know that this flange is 14 millimeters. We assume it's the same here, and it is. So we have a typical dimension. We don't need to run a dimension vertically this way. And the R7, I don't need to put a typical on the end, and I don't need to run a dimension on this side because the center line tells the story of symmetry, right? So I don't need to run the typical. But I do need to know from the base, bottom, to where this slot center line is. So I have that dimension. And I also need a dimension of the height of this vertical flange on top of the base. So I'm going to have to run that dimension either on this view or this view. And both would be correct. I mean, I'm being forced to dimension between views, but I talked about this. You can do this if there's good reason, and there is good reason because I'm at a room off the border here, right? If I was to try to run this dimension from here to here, snap it to the 22 and come out 10, I land right outside the border, which is not good. So I'm going to erase it. I'm going to place that dimension on the front view because, again, that is a better defined profile, right? Again, this is basically in 2D perspective, this vertical flange right against that cylinder. It's easier to understand that dimension seen on the front view. So I'm going to grab my linear dimension. I'm going to dimension from here to here. I'm going to get 33, snap it to the part, and come off 12. And that looks fine. Okay, this one has to be turned into a dimension. So I have an overall height here. I have a 64 dimension that allows me to serve as a overall dimension for this top view. And basically what I need is a dimension that can define the overall length of this, right? It'd be nice to know exactly how long this is. I don't have an overall dimension that shows that. So if we run the dimension, it would be preferred to run it not between the top view and the front view, but let's see if we have room for that. Linear dimension from here to here. It's 117. We're going to snap it to here. And we're going to come down. Whoops. Mistake. Okay, let's try that again. Come down. Ortho on, by the way. All right, so see the problem here? I guess it doesn't quite fit, does it? So we're going to have to kill that dimension, and we're going to have to run it up here where there's room. So between views, like I said, you can dimension between views, but you have to have a darn good excuse. 12. Okay, and that's fine. And that is it. That is all I need to dimension this part. Proper and orthographic. So all of the rules in the sheet that I got over earlier have been satisfied. Now, I believe this will be the last time I do this for you. Feed stop. Stretch this out. Ortho 1, use the move. Date. Today is 09. The 25th. 20th year. One-to-one scale. 201-04. And we might just sneak this over a bit. Okay. And that is it. So that was kind of a long video. That was a lot to discuss. But it had to happen. And thank you for bearing with me through it. And now you're ready to try the carrier frame and the column support on your own. So good luck. Follow the rules of the dimensioning. Remember the tips given in this video. And continue to do great things. So that's it for now. Take care, and I'll talk to you later.